Every message broker on Earth, no matter how fancy, is really just a handful of patterns wearing different logos. Learn these four, and you can walk into any system and immediately understand how the messages are flowing. Interviewers love this because naming the pattern precisely is the difference between "I've used the queue" and "I know what I'm doing." Let's go. Pattern 1. The point-to-point queue, also called competing consumers. One message goes to exactly one consumer. If you put 3 consumers on the same queue, they don't each get a copy. They take turns. The first message goes to worker A, the next to worker B, the next to worker C. It's a work-sharing pool. And here's the beautiful part. If a worker grabs a message and then crashes mid-task, the broker notices the acknowledgement never came, and it hands that message to another worker. Nothing falls through the cracks. Want to go faster? Add more workers. That's it. That's how you scale a task queue. Use this whenever exactly one worker should do the job. Sending a single email, processing a single order, resizing one image. One message, one worker. Pattern 2. Publish, subscribe, or fan out. Now, instead of taking turns, every subscriber gets its very own copy of the message. Publish one order placed event, and inventory gets a copy. Billing gets a copy. Notifications gets a copy. And analytics gets a copy. All at once. The key insight: each subscription is its own independent stream, so adding a new consumer is completely free. You just subscribe, and the producer never even knows you showed up. This is how you build systems where many teams react to the same event without stepping on each other. Pattern 3. Event streaming, the log. This is PubSub's more powerful cousin. It's an append-only log. Messages get added to the end, and, crucially, they are kept around after being read. Each consumer tracks its own position in the log, which we call an offset. So consumer A, doing billing, might be at position 3. Consumer B, doing analytics, might be way back at position 6,000, slowly crunching through history. They don't interfere, and any consumer can rewind and replay from the beginning. That combination, many readers plus durable history plus replay, is exactly why Kafka exists, and we'll spend a whole chunk of this series on it. Pattern 4. Request, reply. Sometimes a consumer actually needs an answer back, so the sender includes 2 things: a reply to address and a correlation ID, basically a tracking number. The responder does the work and publishes the result back to that reply address, tagged with the same tracking number so the sender knows which request it belongs to. This is doing remote procedure calls over a broker. It's common in RabbitMQ, but honestly, it's often a smell. If you truly need a synchronous answer, a direct network call is usually simpler, so use it deliberately, not by accident. Now, one more thing that isn't a topology, but that separates people who've run production systems from people who haven't. The dead letter queue. Here's the scenario. A malformed message arrives. Your consumer tries to process it and fails. The broker re-delivers it. It fails again, and again, forever. And because it's stuck at the front of the line, every good message behind it is now blocked too. One bad message just took down your entire pipeline. This is called head-of-line blocking, and it is a classic outage. The fix is the dead letter queue. After a message fails some number of times, the broker gives up and moves it off to a separate queue, the dead letter queue, so the good messages can keep flowing. Then your ops team can inspect the poison message, fix the root cause, and replay it later. The rule is simple and non-negotiable. Always configure a dead letter queue, and always alert when anything lands in it. A dead letter queue that nobody is watching is just a silent bucket where your data goes to die. Quick last note: push versus pull. In pull-based brokers like Kafka, consumers ask for messages at their own pace, so they can never be overwhelmed. In push-based brokers, the broker shoves messages at consumers as they arrive, which is lower latency but needs a speed limit so a slow consumer doesn't drown. So there they are: point-to-point, pub-sub, streaming, request-reply, and the life-saving dead letter queue. Next episode, we go to the concept that trips up the most engineers in interviews: delivery guarantees, ordering, and the exactly once myth. It's a good